Hello everyone, on behalf of Physics Made Easy Kota, I am welcoming you all in our next lecture, that is electrostatic potential and capacitance. So we are going to learn about the degree of electrification of a body. It relates with electric potential as well as it is a physical quantity. It governs the flow of charge between the bodies so that bodies get electrified. It is a scalar quantity, so the electric field is always related to the electric potential to account about the degree of electrification. Electric potential is considered to be similar to the water potential. So for comparison, we take an example with which motion of water is considered. We all aware that motion of water is from higher level to lower level. We compare this thing with the flow of electric charges that flow from the high potential to the low potential. So therefore, the factor that decides the direction of flow of water is the level of the water, not the amount of the water. From which level the water is flowing, that level decides the direction of the flow of water. So similarly, we can understand that for the direction of the flow of the heat, the deciding factor here is temperature, not the amount of heat. The electric potential decides the direction of flow of charge from one body to another, irrespective of the amount of the charge possessed by the bodies. So now we are going to learn about the transfer of the heat. For this, there is an example. We have two blocks, block A and block B. Block A has higher temperature than block B. So when the blocks are touching each other as shown in this figure, heat will transfer from block A to block B, going from warmer temperature to cooler temperature. So the heat will continue to transfer until the two blocks have the same amount of heat energy. When this happens, the blocks are in equilibrium. That's why this figure is shown in the same color for the block A and block B, as both the blocks are in equilibrium. So there is a potential, higher potential and lower potential, and this potential in electricity decides the direction of the flow of charge from one body to the another body without taking into consideration the amount of the charges held by the two bodies. So we consider the two places. One, suppose that the particle or a charge is at infinity and it has to move to the respective position. So the work done by moving a charged particle from infinity to another point, that work done is equal to the electric potential between any two points in an electric field is defined as the electric potential difference per unit charge. For example, we suppose that a charge is taken from an infinity and it comes to a one particular point. Then we have to move charge from that particular position to the another position. So that amount of work done to carry the unit positive charge from one point to the another point in an electric field against the electrostatic force of field is known as electric potential difference. The most important thing that electric potential difference does not depend upon the path followed, and the units for the electric potential is volt. Now the next most important topic, equipotential surface. EQ means equal, that have the equal potential. That surface is known as the equipotential. So how this surface is formed? The formation of equipotential surface will depend upon the type of the medium and the amount of the charge distribution in a space or in a particular medium. So the surface at every point of which electric potential due to charge distribution is same is known as equipotential surface. So now what is the choice of the equipotential surface? How we represent the equipotential surface for a uniform electric field? Uniform electric field is represented by equidistant parallel straight lines, and the equipotential surface for uniform electric fields are the planes that are perpendicular to the electric field lines representing uniform electric field. So we draw the three planes, plane 1, 2 and 3rd, and these planes are perpendicular to the direction of electric field. The potential V1 at every point on the plate first is same. So plane 1 is equipotential surface. Similarly, we can take the potential V2 which is same at every point on the plane 2. So plane 2 is also equipotential surface. Similarly, we can study about the potential V3 that is same at every point on the plate 3rd. Therefore, the plate 3rd is also an equipotential surface. For isolated point charge, suppose we having the charge plus q and we draw a sphere by taking the radius r along this charge, then all the points on this sphere will have the same potential. Thus we can say that equipotential surface for an isolated point charge are concentric spherical surfaces around the isolated charge. So thank you for watching. If you have any doubt, kindly respond us in the comment section. Thank you. Take care. Have a nice day.